Hey, and welcome to College Mathematics MGF1106 Exam 3. Let's go ahead and get this review going. Remember, if you're joining us, obviously you know where we're at. We're in our online math resources course. If you click on College Mathematics, and then once you're in here, you've got this little tab right over here that says Test Review Materials. So this is where you will find the test review, which we're working on version A. So here is the blank version, the solution guide we are working on right now, and the video is what we are doing. So both of these will be published once the video is done. Okay, so let's go ahead and get this party started. So we have probability and statistics. That's what we're going through here at the end. So the first question says, a person can order a car with a choice of 9 possible colors, with or without air conditioning, with or without automatic transmission, and with or without power windows, and with or without a CD player. How many different ways can we make a new car? So this one is your fundamental counting principle because you're choosing one from each one of these different groups. Okay. So our first choice is color, and there are 9 choices. And we're going to multiply that by our next group, which is all about AC, and there are 2 choices. Either you get it or you don't. The next one is the automatic transition. Sorry, not transition, transmission. Silly, Mr. Armstrong. And that is 2 choices because either you get it or you don't. The next choice is all about power windows, and 2 choices again. Finally, with the CD player, and you got 2 choices there. So what you're looking at with the fundamental counting principle is this. We're going to take 9 times 2 times 2 times 2 times 2. And that will give us our answer. So you just take out your handy dandy calculator. And 9 times 2 times 2 times 2 times 2 is 144 different new cars. And I always write the label out because I think it's important to have those labels. So that way we know what you're talking about. So there's question number 1. Question number 2. So we jump in here. It says a club with 16 members is to choose 3 officers: president, vice president, secretary, and treasurer. If each office is to be held by one person and no person can hold more than one office, how many ways can we fill these offices? So when you look at this problem, because we have a president, vice president, and secretary/treasurer, this is a ranking problem. So all ranking problems are permutations. So remember, with permutations, you got that NPR situation. The NPR, where N is the total, R is the number of choices. So N is your total, R is the number of choices, or your ranking. Okay. So if we fill this in, the total number of people we have to pick from was 16. Our number of choices is 3. So this is 16 P3. Now, you can go and run the formula, which the formula looks like this: n factorial all over n minus r in parentheses factorial. Okay, so that would be 16 factorial on top all over 16 minus 3 factorial. And in the end, that's 16 factorial all over 13 factorial. Okay, Remember, factorials just means that you're taking it from 16 and multiplying all the way down. So 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's being divided by 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you remember some basic algebra skills, numbers that are the same to the bottom cross each other out. So these 13s go away, so do the 12s, so do the 11s and the 10s and the 9s and the 8s and the 7s and the 6 and the 5 and the 4 and the 3 and the 2 and the 1. So really all you have left is 16 times 15 times 14. That's what's really going on. So in the end, the answer is 3,360 different choices of officers. But doing this is extremely long. Just let your calculator do all this hard work. You can put this in the TI-84 calculator. Why do all this work? Okay. So if you just go to your calculator and you hit math, scroll over to the word prob. Hey, NPR. Scroll down to it. And all you got to do is put in 16. Scroll over to the next box. Oop, too far. Hit 3. And boom, there's the answer. So I'm not going to show you the long way anymore. Okay. I'm always going to go to that calculator. But that's really what's going on. That's what factorials mean. Okay. And also, if you saw on your calculator, if you wanted to, math, go to prob. Hey, there's the factorial. So you could have come out here and put 16, math, go to prob, scroll down factorial, divided by 13. Go to math, scroll all the way to prob, factorial. And there's your answer too. So lots of ways that you can do it. All right, so number 3. Number 3 says that they want to know how many distinct permutations, so you know this is a permutation, can be used or can be formed using the letters of the word connection. Now, this is one of those permutations where you have duplicates. So I've got 2 C's, I've got 2 O's, I've got 3 N's, and that's it. So this one's a little different. So I'm going to write out the word. And then we'll go talk about how we work this. Okay. So we got our word. So remember with duplicates, you have a formula that's n factorial, so your total on top. And then you have factorials down below of your duplicates, so on and so forth. So let's do this. Let's fill in. So n is our total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got 10 factorial on top. And then down below, you got to put your duplicate factorials. So as we said a moment ago, C is a duplicate. And there are 2 of them. So that's 2 factorial. O is a duplicate. There are 2 of them. So that's 2 factorial. N is a duplicate. There are 3 of them. So that's 3 factorial. E doesn't repeat, T doesn't repeat, I doesn't repeat. So there it is. This is what we got to put into our calculator. So you can't use the NPR, but you can use what I showed you a moment ago. Now, in this one, because it looks like a fraction, I'm going to go ahead and make this look like a fraction. So I've got 10. Go to math. Prob, go down to your factorial. So there's our 10 factorial. And then down below, all I got to do is put in my other factorials. 2, math. Go over to prob, factorial. And then the 2, math. Prob, factorial. And 3, math. Oops, sorry, clicking the wrong one. Factorial. And there it is, just like how I wrote it. And hit enter. And that's how many different ways we can have distinct arrangements of the word connection. 151,200 distinct word arrangements. Let that calculator do all the hard work for us. All right, number 4, moving right along. Okay, number 4, to win the lottery in one state, one must correctly select 7 numbers from a collection of 47 numbers. The order in which the selection does not matter. How many ways can we win the lottery? Okay. So this one, because the order doesn't matter, I just need 7 numbers. This is what we call the combination. This is NCR. The N and the R are the same meaning as what they were before. N is the total, R is the number of choices. Okay. So if we fill in this NCR, the total number is, well, how many numbers are we picking from? And that's 47. We're using numbers 1 through 47. How many do I get to pick or choose? I'm only going to pick 7 of them. So that's 47C7. Again, it has a formula, but I'm going to show you what the formula is, but I'm not going to work it out like what I did before. So your formula is n factorial all over n minus r factorial, r factorial. Okay. So if I fill this in, and that's as far as I'm going, we'll have 47 factorial on top with 47 minus 7 factorial on the bottom, 7 factorial. So in the end, you'll have 47 factorial all over 40 factorial, 7 factorial. Okay. But let's just have the calculator do the hard work for us. So again, you'll go to math, scroll all the way over to prob. Hey, there's the NCR. So we'll choose it and we'll put 47, scroll over, 7. And there's our number. So there are, looks like 62,891,491 different lotto tickets. That's why it's tough to win the lottery. All right, moving on. Number 5. And if you haven't noticed, it's pretty much been going in order of the way that you learned it, just like all the other exams. Okay, so number 5, a 12-sided die is rolled. The set of equally likely outcomes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Find the probability of rolling an 11. So here we're working on probability. This is one of those theoretical probability. Number 6 is your experimental probability because we actually did an experiment. So what is the probability of rolling an 11? So remember, probability for us is all about number of ways you win over total number of outcomes. So what we want to happen, the ways that we can win, all over the total number of outcomes. Well, how many ways can you roll an 11 on a 12-sided die? Only one way. Either you roll the 11 or you don't. Out of how many outcomes? There are 12 outcomes. And that right there is your probability. Always make sure that you check your fraction to make sure it doesn't reduce, and 1/12 does not reduce. So it's good to go. Number 6. So number 6 says the table shows the educational attainment of a country's population age 25 and over. Use the data in the table expressed in millions. So this is like 12 million, 21 million, to find the probability that a randomly selected citizen age 25 and over, which all these people are age 25 and over, was a woman with 4 years of college or more. So we need to first find out. So actually we want the probability of being a woman or female with 4 or more years of college. I'll just call that 4 or more. So that's the probability we want. Well, here are the females. And we want 4 or more. So that's in this column right here. So there's the way we win. So that's 18 out of, well, how many people are there total? And we're talking everybody. So that's this number right here in the corner. There are 160 people total. So this is the probability that you're looking at. 18, because there are 18 females with 4 or more years of college out of 160. Now we just go to our handy dandy calculator. We hit alpha y equals, and we're going to check this fraction because it will reduce. Put in your 18, put in your 160, enter, and that's the answer you're looking for. 9 over 80. And boom goes the dynamite. Number 7. All right. Sergio, Eduardo, Simone, Sarah, Larry, and Jim have all been invited to a dinner party. They arrive randomly, and each person arrives at a different time. So this one is a 4-parter. Hopefully this one looks and sounds familiar. So we've got 1, 2, 3, 4, 5, 6 people. 2, 3, 4, 5, 6. Sorry, just doing a little bit extra work. Got to write some stuff down. Okay. So let's talk about this. So we've got 6 people coming to a dinner party. They're all coming and they arrive one at a time. So this is the fundamental counting principle. Okay. So the reason being, because this first person, you got like different groups here. Okay. You got so many ways the first person can come, so many ways the second person can come, so many ways the third person can come. You've got different groups, and the groups are the different ways each person can come. All right. Or I shouldn't say the different ways each person can come, the different times each person can come, whether you're first, second, third, fourth, fifth, sixth. All right. So how many ways can the first person come? Well, the first person, there are 6 people. So there are 6 different ways the first person can come. Once that person is at the party, you can no longer use them again. Okay. So how many ways can the second person come? Well, there's only 5 people left. So that's 5. The third person, There's only 4 people left, so that's 4. Hopefully you've seen the trend. So we're just going to take 6 times 5 times 4 times 3 times 2 times 1. And there's our answer for part A. Or you can just do 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. So there are 720 different arrivals. All right, now let's talk about part B, because this is a scaffolding question. We're going to use this number to help us in part C. So part B says, how many ways can Sergio arrive first and Jim arrive last? So we now know Sergio is the first person to arrive. Jim is the last. So these two people are stuck. They're already accounted for. So now let's worry about how many ways these people can arrive. Well, with these two already accounted for, that means I only have 4 guests left. So how many ways can the second person arrive? 4. And then because these two have already arrived and Jim is already accounted for, there's only 3 people left now. So there are 3 ways for the third person to come. And then 2, and then 1. So all we have to multiply is 4 times 3 times 2 times 1, which is 24 different arrivals with Sergio first and Jim last. So the last question says, what's the probability of that situation? What's the probability of Sergio first and Jim sixth? Well, there are 24 ways of this happening out of a total of 720 different ways it could have happened. And again, go to your calculator, alpha, y equals, put in your fraction, 24 all over 720, not 60, 20, Mr. Armstrong. And the probability is 1 out of 30. And there you go. Moving on. Almost clicked on the wrong one. Number 8. A group consists of 5 men and 6 women. 4 people are selected to attend a conference. And how many ways can 4 people be selected from the group of 11? How many ways can 4 women be selected from the 6 women? And then find the probability that the selected group will consist of all women. So again, another one of those scaffold problems. Okay. Cool thing about this is we're selecting people to go to a conference. So in this case, this is an order, doesn't matter. I just need 4 people to go to a conference. I'm like, you, and you. You're going. Doesn't matter. I'm not ranking anybody. So this whole problem is a combination problem. Okay. So part A says the number of ways 4 people can be selected from a group of 11. So that is, for us, 11C4. So you just go to your calculator and put in math prob 11C4. All right, so there are 330 different ways to, well, that's a lot. Let's just say there are 330 different conference teams or attendees. That's a little bit better. Conference attendees. There we go. So part B, wrong page. Part B says the number of ways you can select 4 women from a group of 6. Well, right there, we're going to have 6 C4. So 6 C4. So again, you just go to your calculator, do all the work, let it do all the work. So 6 math, I'm just doing this on my side calculator, E4. So there are 15 different female conference attendees. And last but not least, just like before on number 7, we're going to put it all together in part C. So part C says, what's the probability of all women? Probability, all women or females. Okay. So the probability of our event, we win if it's all women. So that's 15. 15 different ways to accomplish that. And how many different ways total? 330. So you just go to your calculator. I'm going to start cutting out some of that calculator work. So alpha y equals, just doing this on my side calculator here, 330. So the real answer is 1 out of 22. That's what it reduces to. All right. Moving on, we're getting near the end of probability, and then we'll hit up the statistics. So we're on problem number 9. Number 9, it says you are dealt 1 card from a 52 card deck. Find the probability that you are not dealt a queen. Okay. So when you are not dealt something, so we want the probability of not a queen. A quick way to find the probability of not a queen, take 1 minus the probability of getting a queen. Well, that's easy to do. 1 minus, well, the probability of getting the queen. Well, how many queens are there in a deck of cards? And there are 4. The queen of hearts, the queen of spades, the queen of diamonds, and the queen of clubs. So there are 2 blacks, 2 reds, 4 queens total out of how many cards? 52. So if I take 1 minus this, I get 48 out of 52, which will reduce to 12 out of 13. And there you go. There's the probability of not being dealt a queen. All right, 10. You randomly select 1 card from a 52 card deck. Find the probability of selecting a 6 or an ace. Okay, so this is an or question. We want the probability of a 6 or an ace. So remember with ORs, you have to know what the situation is first. Remember, ORs are all about mutually exclusive or not mutually exclusive. Remember, mutually exclusive means they cannot happen at the same time. They cannot happen at the same time. So if I draw a card, is it ever possible that I draw a card and I get a 6 of aces? And the answer is no. Either your card is a 6 or your card is an ace. There is no card that is called the 6 of aces. So this is what we call mutually exclusive. They cannot happen at the same time. So all we have to do then is find the probability of a 6, and we're going to add that with the probability of an ace. That's it. So the probability of a 6, well, how many cards are 6 in a deck of cards? There are 4. Again, like the queen, the 6 of hearts, the 6 of diamonds, the 6 of spades, the 6 of clubs. There are 4 out of 52. Plus, what's the probability of an ace? Well, again, there are only 4 aces out of 52. Because you got the ace of hearts, the ace of diamonds, the ace of spades, the ace of clubs. So if I add this together, I get 8 out of 52. Or in other words, I believe this should be 2 out of 13. Yes. There's the probability of drawing a 6 or an ace. Number 11. Okay. Number 11. The mathematics department of a college has 6 male professors, 10 female professors, 11 male teaching assistants, and 15 female teaching assistants. If a person is selected at random from the group, find the probability that the selected person is a teaching assistant or female. So again, another or. So a TA or a female. Okay. So the question is this mutually exclusive or not? And again, to be mutually exclusive, they cannot happen at the same time. So is it possible that I can have a female teaching assistant? And the answer is yes. So these two can happen at the same time because right here, 15 female teaching assistants. So this event is not mutually exclusive. So that means what we're going to be doing is we're going to find the probability of a teaching assistant. We're going to add that with the probability of a female, but we have to subtract out the probability of female teaching assistants. Because what happens when we add these two is we're counting these female teaching assistants twice, and we got to take out the doubles. Okay? So let's get the probability of a teaching assistant. So we jump back to this. First, teaching assistants. Well, we have 11 male teaching assistants, 15 female teaching assistants. So that's a total of 26 teaching assistants out of, well, there are 6 male and 10 female, so that's 16. So 26 plus 16, 42. Okay. Yes, 42. All right, just double checking that. All right, well, how many females are there? Well, there are 10 female professors and 15 female teaching assistants. So that's a total of 25 out of 42. The bottom number doesn't change. Minus, now we got to subtract out the people that we counted twice, and that's the female teaching assistants, which is 15 out of 42. So this is what it looks like. There's all the teaching assistants. There's all the females. These are female teaching assistants. So if you go and do your math, you end up with 36 out of 42. But that reduces down to 6/7. And there you go. All right, number 12. Oops. All right, so it says one card is randomly selected from a deck of cards. Find the odds against drawing a 5. So we want odds against, okay? So on top, these are all the ways we lose. On bottom are all the ways we win. Okay, so this is different. These are not totals, but these are the number of ways we can lose, the number of ways we can win. We want odds against a red 5. Okay. So just do this. Odds against a red 5. So right down here, the ways we win is with a red 5. So how many red 5s are there? There are 2. There are only 2 red 5s. The 5 of hearts and the 5 of diamonds. Now, how many other cards are there? Remember, there are 52 cards in a deck. So if we take 2 out of that, that's 50. But again, this must be reduced. Okay. So these are all the ways we lose. Ways we win. Okay. So if you reduce this though, this will become 25 to 1. And that's what they're looking for. Make sure you reduce it. It's like a fraction. Both numbers can be divided by 2. All right, so there's number 12. Number 13. We're getting there. Almost done. Promise you. Almost done with the probability. I think after 13. Nope. After 15. After 15, we are done with probability. All right, 13. So you draw one card from a 52 card deck. The card is replaced in the deck and shuffled. Then you draw again. Find the probability of drawing an ace and then a club. So the probability of drawing an ace, then club. So this is an and. This is an and. Okay? I should have probably actually wrote the word and in here. So we want to draw an ace, and then we want to draw a club. Let's fix this. So with ands, why that dries for a second, we have to consider what is the situation. So remember with ands, it's all about independent versus dependent. Remember, independent events mean that the first event does not affect the second event. Dependent, the first one will affect the second one. Okay, so this one, the key to this is the fact that they said that you will replace the card. That means there is with replacement. Remember, whenever I told you in class, whenever you see that with replace or you're putting it back with replacement, that's always going to be independent. Without replacement is dependent. So this is definitely independent. Because the moment I put that card back, it's the same deck. So I have the same chances of drawing every card again. All right. So now that we've got everything fixed. So because this is independent, all we have to do is find the probability of an ace. And we're going to multiply that by the probability of a club. All right. Well, we already talked about the probability of an ace earlier. There are 4 aces out of 52. We're going to multiply that by the probability of a club. Well, how many clubs are there? There are a total of 13 clubs out of 52. Because you have an ace of clubs, and then you have 2 through 10. So there's 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 cards. And then you have the jack of clubs, the queen of clubs, the king of clubs. So that's 13 cards total. So all we have to do is just multiply those two. So 4 times 13 is 52. And 52 times 52 is 2,704. But again, we always reduce. So 52 divided by 2,704 is 1 out of 52. That's our probability. All right, 14. So in 14, it says Elizabeth brought a box of donuts to share. There are 24 donuts in the box, which means 24. All identical in size, shape, color. There are 4 jelly-filled, 10 lemon-filled, and 10 custard-filled. You randomly select one donut, eat it, and then select another one. Find the probability that you choose a jelly-filled, and then you choose a lemon-filled. All right. So jelly-filled, then lemon-filled. Remember, you eat it between. So is this independent or dependent? And in this case, this is going to be dependent. Because the moment you eat the donut, you're not going to regurgitate that back up and put it back in the box. So the moment I eat a donut, it's different for me choosing the next donut because there's not the same amount left. So what you're going to do is we're going to find the probability of a jelly-filled first. We're going to multiply that by the probability of a lemon-filled, given that we ate the jelly-filled. Okay? All right. Well, what's the probability of a jelly-filled? Well, there are 4 jellies out of 24 because it's 24 donuts. All right. Now, remember, we ate a donut, so there's only 23 left. See how this is now dependent because we have changed this guy. Out of how many lemon-filled? Well, we didn't touch the lemons, and there are a total of 10 of those. Let me just double check those numbers. 4 jelly-filled, 10 lemon-filled. Good. We're perfect. So we go back, and all we got to do is multiply. Top is 40. The bottom is 552. And of course, we reduce that. And we get the fraction 5/69. And there's your probability. Number 15, our last probability. Our last one. And then we'll go to statistics. So we have in number 15, 2 of them that we're going to be dealing with here, kind of like an A and a B. The first one we'll be dealing with the actual fraction, and then you will round that answer. So here it says express the probability as a simplified fraction in a decimal. If one person is selected from the population described in the table, find the probability that the person has never married or is divorced. So we need the probability of never married or divorced. Since this is an or, we got to think about, okay, is this mutually exclusive or not mutually exclusive? So in other words, can you never be married and divorced at the same time? And no, you can't. Okay. Nope. That's impossible. So this is mutually exclusive. So that means all we have to do is find the probability of never married and multiply that by the probability of being divorced. Actually, not multiply. Sorry. Add the probability of being divorced. So let's find the probability. What is the probability of never being married? Well, how many people are never married? And that's 80. Out of how many people total? 254. And we're going to add that with, what's the probability of being divorced? Well, probability of being divorced is 30 out of 254. So this is what we're looking at. Because there were 80 that were never married out of 254 and 30 that were divorced out of 254. So in the end, you get 110 out of 254. And that will that will reduce to 55 out of 127. So there's the first answer. And then the second answer says round to 2 decimal places. Let me make sure on that. 2 decimal places. So you just go to your calculator, 55 divided by 127. 2 decimal places. So it's right here. So this 3 says, hey, 3, stay the way you are. So 0.43. There are your 2 answers. Okay. So 0.43 goes in the second blank, 55 over 127 in the first blank. And that right there wraps up probability. Number 16. We're almost done, I promise you. Almost done. See how many questions there are? There are a total of 27 questions on this. So we're getting there. These last few questions should go pretty fast. All right. Too far. All right. So 16. It says the government of a large city needs to determine whether the city's residents will support the addition of another firehouse. The government decides to conduct a survey of a sample of the city's residents. Which one of the following procedures would be the most appropriate for obtaining a sample of the city's residents? So, should they survey a random sample of firemen who currently work in the city? Should they survey every 10th person who uses the public restroom? Should they survey the last 100 residents listed in a telephone directory? Or should they survey a random sample of persons within each neighborhood? So hopefully you said that they should survey a random sample of persons within each neighborhood. Hold on 1 second, writing this out. So let's talk about why the other choices are no good. No bueno. So the first one is you're surveying only firemen. Of course, they're going to say, let's build another one. Why not? Okay. So it's a little bit biased in that one. The firemen are going to say, yeah, sure, let's do it. All right. The next one, survey every 10th person who uses the public restroom. There are some people out there that do not touch public restrooms. So they are not going to go in there and use it. And that's a little weird to be asking people that are coming in or maybe out of a restroom about whether they think we should build another firehouse. Okay. Surveying the last 100 residents in the telephone directory. Well, that would be like everybody with the last name of Z. And that's not very, that doesn't depict everybody that would be affected by this. Okay. Because maybe all those people that have the last name Z live in one corner of the city. So again, kind of like surveying the restroom people, it's a little weird. Your last one is what's going to make sure that it's fair and it seems appropriate for the city, because you're going to talk to everybody within each neighborhood of the city. So that's the fair piece. All right, number 17. So you're kind of doing like a frequency table here. Okay. And so in these blanks, you're going to tell me the number of tallies you have for each group. Okay. So give me 1 second. I'm going to create this table again. 50, 51 to 55, 56 to 60, 61 to 65, and 66 to 70. So this is the frequency. Okay. So all you got to do is take these numbers and put them in the groups. So 56 will go in the 56 group. The 59 will go in the 56 group again. The 49 will go in the 46 group. The 42 will go in the 41. 42 will go in the 41. I'm just making tallies on my piece of paper. I'll show you here in a second. 53 goes in the 51. The 60 goes in the 56 group. The 49 all the way back in the 46 group. 52 is in the 51. 57 is in the 56. 45 is in the 45. 64 is in the 61. 60 is in the 56. 59 is in the 56. 57 is in the 56. 47 is in the 46. 65 is in the 61. 69 is down in the 66. 52 is in 51. 59 is in the 56. 54 is in the 51. 58 is in the 56. 67 is in the 66. 52 is in your 51. 57 is in the 56. 45 is in the 41. 45 is in the 41. 60 is in the 56. 43 is in the 41. 53. And see how I'm kind of trying to keep track of this, because it's so easy to lose your numbers. So 50 is in the 46. 42 is in the 41. 61 is in the 61. 52 is in the 51. 54 is in the 51. 45 is in the 41. Almost done. 57 is in the 56. 64 is in the 61. 55 is in the 51. 49. Okay, 49 is in the 50. 64 down in the 61. 51 is in the 51. 63 is in the 61. And 65 is in the 61. So in the end, in each one of these blanks going from top to the bottom, in 41 to 45, there should be 1. The number 8 in 46 to 50, 5 in 51 to 55, 10 and the 56 to 60, 12, 61 to 65, 7, and 66 to 70, there are 2. So let me check something here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18. So 36, 37, 38, 39, 40, 41, 42, 43, 44. So I've got 44 numbers. If I add all these numbers up, 44. Okay, so 8 plus 5 plus 10 plus 12 plus 7 plus 2, 44. So it checks out. I got everybody. So that's the one thing about this question you got to be careful on. Make sure you don't miss anybody. So it goes 8, 5, 10, 12, 7, and 2. Just to show you what I did. See, there it is. These are the tally marks I made. You just count them all up. And there you go. It's number 17. Number 18. All right. So here we're going to select graphs. So I'm going to tell you which ones they are. This is what I'm going to call top left, top right, bottom left, bottom right. And the same thing for part B. Okay, so that way I don't have to redraw the graph. Now, all you really got to do on this, I'll read the question to you, but really it's just all about making sure which graph shows the following information. So at 0, there should be a bar at 3. When it's the polygon piece at 0, there should be a dot at 3. And then at 1, there should be a dot at 2. And down at 10, there should be a dot at 13. At 9, there should be a dot at 16, so on and so forth. So what you're looking at, it says students were asked, how stressed have you been in the last week on a scale of 0 to 10, with 0 being not at all stressed and 10 being stressed, 10 being as stressed as possible. The students' responses are shown in the frequency distribution below. Construct a histogram and frequency polygraph. So obviously, you know, the top left is out because 0 doesn't even have any. And we should have a bar at 3. So if we look at these other graphs, again, this is above 10. That's too high. This one looks like it's right at 10. Again, too high. So the only one that makes sense is this bottom left graph. Because this is the one that has 10 at 3. And at 1 is at 2. And if you look down here, this looks to be about 13. That looks to be about 16. So this is matching that data. Now all you have to do is find a polygon graph that matches it. Obviously, again, bottom right you can throw out because it looks just like this one that's right up here, the top left. This graph doesn't make any sense. Okay, so looking at the rest of them. So again, this guy's too high. This guy's too high. So this one makes sense. So again, it's the bottom left. Okay. Both bottom left graphs match the data in the frequency distribution. All right, moving on. Number 19. I think number 19 is our, sorry, I was already on it. Yep, stem and leaf plot. So there's two pieces to this. We're going to do the stem and leaf. So 2, 3, 4, 5, and 6. Leaves. And then we are going to answer a question about it. So down here, it says a random sample of 40 college professors is selected from all professors at a university, and they give their ages. Okay, so we're going to make a stem and leaf. Now, in here, it says use ascending order. Okay, so that's good. So we need to have them in order. With that being said, let's go ahead and put in all of our information so we can get this question done. Okay, I believe they will also allow you to have commas between your numbers. Let me double check that. Let me make sure, because I have the answer key that's right over here. Let's make sure on that. Exam 3 answer key. And again, we're working on the answer key right now. So I'm going to check. Yep. Okay. 8, 5, 10, 12, 7, 11. Good. Yeah, so they do put them in ascending order. No commas between them. I've seen them before where they didn't put them in ascending order, and it drove me nuts. So I'm glad they went back in and fixed that. All right, so good. All right, so no commas and ascending order. So we got 66. So remember when you do this first part, so you see how my cursor right here kind of turns into the like an eye, like a selection tool. So to the left of my little selection tool, that is the stem. So that's 6. And to the right is the leaf. So I'm going to put a 6 on the stem 6. So the next one will be a 7 on 4. And then I will have a 2. And then we will have the 40, so a 0. And then a 2 and 3. And a 3 and 5. And a 3 on 4. And a 0 on 4. Another 0 on 4. A 1 on 2. Then a 3 on 5. 4 on 6. 4 on 5. A 9 on 4. A 6 on 6. A 4 on 6. A 2 on 5. An 8 on 4. A 2 on 5. An 8 on 2. An 8 on 3. A 1 on 6. A 4 on 4. A 9 on 4. A 1 on 3. A 6 on 3. Another 9 on 4. A 7 on 3. A 2 on 9. A 0 on 4. A 1 on 6. Again, these two problems are kind of your longest. The one where the frequencies and the one with the stem and leaf plot. So 6 on 3. An 8 on 3. And 6 on 4. A 2 on 1. 4 on 3. another 6 on 4, a 1 on 3, a 7 on 3, and a 7 on 5. So there should be 40. So here's what it looks like if I actually just kind of filled it in. But of course, these should be in proper order. Where'd you go? So then you should go back and put these in their proper order. But this is what it looks like. Notice everything's kind of lined up. Stem and leaf plots should be lined up like that. No commas. So if I put everything in order, then obviously for the 2s, it should go 1, 1, 8, 9. Oh, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 23, 24, 35, 36, 37, 38, 39, 40. Good. I've got them all. You should always double check that too. For the 3s, you should have 1, 1, a 2, 3, but 1, 4, no 5s, 2 6s, 2 7s, and an 8. So there's the 3s. 6, 7, 8, 9. 6, 7, 8, 9. 2. Whoa, missed one. What did I miss here? 2 8s. See? So easy to miss one. That's why I double check my counting. I'll put another 8 there here in a moment. 4s. So we got 1, 2, 3, 4 zeros. 1, 2, 3, 4. 1, 2, 1, 3, 1, 4, 2, 3, 4. Put another 8. There's that to wrap up 3s. No 5s. 1, 2 6s. 6, 6, 1 7, 1 8, 1 2 3 9s. So there are the 4s in order. Good. All right, and the 5s. So 2, 2, 3, 3, 4, 7. And your 6s. 1, 1, 4, 4, 6, 6. And there we go. Those are the numbers that will go in those blanks. Right there. So part B says, what does the shape display? So I don't have to have these in order, but if we come down here and look at it, so here's kind of like our display. Remember I told you that if you turn it like this, it's now in the form of a histograph where these are your bars. So it looks like we got a huge trend right here. So let's take a look at some things. Let's see what it says. All right. So it says, if you are younger than 30, you cannot be a college professor. Well, we know that's wrong because we have 4 people that are younger than 30. We got 2 21s, 28, and a 29. So we got 4. None of the professors lived to be 70 years old. Well, I mean, we just selected a random. We don't know if there are any 74 years old, and this doesn't say any of that. You can't conclude that, but I definitely know that there are some professors that are 70 years old out there. So we know it's not B. The greatest number of college professors are in their 40s. That's the answer. So part B is all about choice C. Because if you look at our histogram, if you look at our stem and leaf plot, that makes sense. Here's the 40s. And we had the most number of people there. There were 14, I believe. So there you go. So the answer for part B is C. Easy peasy, lemon squeezy. Number 20. Not too much further. All right. Number 20 says, find the mean, or in other words, X bar. Remember I talked about that. So in order to find the mean, all you got to do is add all these numbers up. 52 and plus 57 plus 57 plus 59 plus 60 plus 63, and divide that by however many numbers you had, which were 6. So we're adding these numbers up, and then we're going to divide it by 6. And it says to round to 3 decimal places if needed. Okay. So you just go to your handy dandy calculator, and 52 plus 57 plus 57 plus 59 plus 60 plus 63 gives us 348. And we're going to divide that by 6. So when you divide that by 6, answer's 58. So there you go. The mean is just the average. Add it all up, divide by the total. So there's number 20. 21. 21 says find the median. Well, in order to find the median, you got to put your data in order. Okay. So we got 3, 4, 5, 5. So 3, 4, 5, 5. We got a 6, we got a 7, a 9, and a 10. 6, 7, 9, 10. And just to make sure, 8 numbers, 8 numbers. Okay. So median means middle. So all we're going to do is jump our way to the middle. So we jump, and we're stuck between these two. Remember that when you're stuck, all you're going to do is add them and then divide by 2. And so this is going to give you 5.5. There you go. There's the median. And it said round to the nearest 10th, which we didn't have to because it was already at the nearest 10th. So there's 21. 22 is all about the mode. So remember, mode means most. So if you look up here, I've got 2 42s. Everyone else happens once. So the mode is, you're going to select A, and it is 42. So you'll click on A and you'll say 42 is your mode because it's the number that happens the most. It happens twice. Everyone else is only once. All right. 23, I want you to find the mid-range. 23, find the mid-range. Okay. So the mid-range for us sorry about that little pause. I had to go and check on something real quick. So mid-range, all you're going to do is take the largest data entry, add it with the smallest data entry, and then divide by 2. So when you look in here, our largest data entry is 97. We're going to add that with our smallest, which is 91. And we're going to take that answer and divide it by 2. That's how you find your mid-range. So 97 plus 91. Oops. Is 188 divided by 2, which will give us 94. And there's our mid-range. Okay. Next one says, find the range. In order to find the range, all you do is you take the highest number minus the lowest number. So the cool thing is they already got everything in order for us. So our highest number is 22 minus our smallest number, which is 20. And that gives us 2. There's the range. Standard deviation. Let the calculator do this work for you because this is an entirely huge formula. Just let the calculator do the work. So you'll round to 2 decimal places. So in the calculator, you're going to go into stat. You're going to go and we're going to put our numbers in edit right here. So our numbers are 95, 95, 95, 95. So 4 9s, 4 5s. So we're going to go stat and we're going to open up the edit. Let me just clear that out. Hopefully yours will be clear, but if it's not, just scroll up to the L1, hit clear, and then hit enter. And all we're going to put is 9, 5, 9, 5, 9, 5, one more 9, and one more 5. So we have 8 total. Then you're going to go right back into stat. You're going to scroll over to calculate, and you're going to run this first guy. 1 variable statistics. Hit enter. This should say L1. If it doesn't, just hit second and 1. See, now it's L1. And then scroll down to calculate and hit enter. And right here, this S of X, that is your standard deviation. So our standard deviation is 2.1380, blah, 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 blah. And it says to round to 2 decimal places. So 2 is here. So the 8 says, hey, 3, go up. So our standard deviation is 2.14. And there you go. Just let the calculator do the work. Almost done. Number 26. And then 27, and we're done. So when you're done with this, you can just hit clear. See, gone. All right. So it says not everyone pays the same price for the same model of a car. The figure illustrates a normal distribution for the prices paid for a particular model of a new car. Okay. So down here, these are in thousands. This is 24,000, 22,000, 20,000, so on and so forth. The mean is 24,000. That's why it's in the middle. And the standard deviation is 2,000. So you can see why it keeps going. 24 plus 2 is 26, plus 2 is 28. The same thing on the other side. 24 minus 2 is 22, 20, and 18, because you keep adding or subtracting. So it says, what is the percentage of buyers between 18 and 30? Well, here's 18 and here's 30. What's the percent? Well, if you come up here, it tells you the percentage right here. From 18 to 30, it's 99.7%. And that's what goes in the blank. 99.7%. And last but not least, number 27. So number 27 says, scores on a dental anxiety scale range from 0, no anxiety, to 20, extreme anxiety. The scores are normally distributed, which is what this is, with a mean of 11 and a standard deviation of 4. So this would have been like the 11 in the middle, and then you would count up by 4s from 11 and down by 4s from 11. Find the z-score. So we got Z7. So the formula for a z-score is as follows. You're going to take, sorry, almost messed this up. Where's my, there it is. So the formula for a z-score, you're going to take your data entry. Give that a moment to dry. So right here is going to go data. We're going to subtract the mean from it, and divide by the standard deviation. Okay. So our data score is 7. We're going to subtract the mean, which was 11, and divide by the standard deviation, which was 4. Okay. This is your data. So you just go to your calculator. 7 minus 11 is -4. And -4 divided by 4 is -1. There's your z-score. And that's it. That, my friends, is the exam 3 review. I hope you had as much fun as what I did. You guys got this. I wish you good luck. Thanks for stopping by.